Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to further elaborate on the lack of understanding on the part of mainstream academics and their flawed calculus, or what I like to call their bogus mainstream formulation. So let's begin. Now, I've got two functions on my screen here in GeoGebra. This is the function f in blue and its derivative in red. Okay, and this here is simply a template that I use to determine the limit from both sides. So first of all, what is the mainstream definition of the MVT state? It states that if a function f is continuous on the closed interval and differentiable. Now I've crossed this out because there are occasions where it need not be true, and I'm going to give you one such occasion, which is a counterexample to this here. Okay, so generally, yes, it does have to be differentiable, but not in this example that I'm giving you. If it's differentiable on the open interval AB, then there exists a point C in the interval AB such that f prime of C, or the derivative at C, is equal to the function's tangent slope at C. Okay, so you can see that from this statement, I'm going to demonstrate to you now that if we try to see what happens here at x equals 4, okay, there is really no tangent line there, or actually no derivative, but ironically, according to your mainstream mathematics professors and teachers, there is a tangent line here, and I've always stated that you cannot have a tangent line at a point of inflection. Okay, that's just simply not possible. And even though this is a minimum point, it is in an indirect sense also an inflection point, because this is where it changes. Okay, so what I'm telling you here is that there is no derivative at x equals 4 if you use this bogus, flawed, or totally senseless definition. But you will still find that the tangent or the derivative is defined at x equals to 4. So you have no derivative here, right, using your limit method, but you do have, and it's actually equal to 0. So f prime of 4 is the derivative of f at x equals to 4. So back to the statement here, this condition here does not hold for this counterexample I've given you. Okay, and I'll let you download this applet. I'll give you a link to it. So that's the first thing. Okay, and also, if you study this carefully, you'll see that mainstream academics cannot understand the mean value theorem. They don't realize that the fundamental theorem of calculus is the mean value theorem. Okay, and if you go over my previous 2 or 3 videos, you'll see why. I'm not going to go over that again. So what is the conclusion? So the conclusion is that we must have that f is differentiable, so this must be differentiable, with the exception being at points of inflection or maxima or minima, where logically there cannot be a tangent line. So here there is no tangent line here to the blue curve, isn't there? But at the same time, f prime of 4 describes the derivative. So it's obviously garbage, isn't it? Okay? And in my counterexample, you see there is no derivative to f using your bogus limit definition, but nonetheless, f prime is defined at x equals to 4, meaning there is a tangent line slope. But once again, your bogus or your idiotic mainstream academia will tell you that there's a tangent line through this inflection point. Of course, this isn't related to this particular example, but they'll tell you that there's no tangent line here, but there is a derivative here. So in the new calculus, we don't find these contradictions. A tangent line always implies a derivative, and a derivative always implies a tangent line. This is not the case in your garbage mainstream formulation. Okay, so You know, next time some idiot says, oh, but the cubic function doesn't have a tangent line using the new calculus. It's not meant to have a tangent line, you morons. Do you understand that? You cannot have a tangent line at a point of inflection because there are only half tangents at inflection points. So there is no derivative, strictly speaking, at a point of inflection. And unlike your bogus calculus, where sometimes there is a tangent line and no derivative, and sometimes a derivative and no tangent line, this sort of thing doesn't happen in the new calculus. And moreover, it does not affect the mean value theorem. The mean value theorem does not care about inflection points. Did you get it, you dimwits? Well, all right, I hope those of you who have a brain and are able to think will understand these things. So I've been through this material in the past, but it seems to me that the majority of the idiots and the moronic students who listen to their professors and can't think for themselves keep on posting stupid comments. So wake up, because this is the very last time I will tell you about this. My name is John Gabriel, and if you haven't already subscribed to my channel, subscribe, because you'll become a lot wiser than you are and a lot smarter than all your professors combined. Because I do know better, I am smarter than you. That's just a fact, it's not arrogance. So, I'm going to leave it at that. You can donate credits or money at the link to my Odyssey channel, which I shall place in the details section. Till next time, goodbye.